Addition polymers. Synthetic polymers are organic molecules that are formed synthetically by joining smaller molecules called monomers. There are two types of synthetic polymers, which are addition polymers and condensation polymers. So what are addition polymers? Addition polymers are formed by joining up many small molecules of the same type called monomers. So many of these small monomers are joined together to give you the polymers, and alkenes can be used to make polymers by addition polymerization. So the main monomer of addition polymerization is the alkene. Alkenes can be used, as we can see, because alkenes have double bond, and this double bond can break up and can open to add more molecules, and then we're gonna get the polymer like polyethene, which is formed from many monomers of ethene, and now there is no more double bond in the polymer formed. How can we draw the addition polymer? So if we know the structure of the monomer, we can use this structure to draw the addition polymer structure. So let's start off with a chloroethane or vinyl chloride. So vinyl chloride molecules, monomers, will react together in addition polymerization to give you the polymer polyvinyl chloride or polychloroethene. First of all, you need to open the double bond between the two carbon atoms of the ethene or of the alkene, and then you're gonna get the polymer backbone. Then now you need to start drawing or fill in the groups as they surround the double bond. Here we have four different groups or four different atoms. Three of them are hydrogen and the fourth one is chlorine. So we simply draw the three hydrogen and chlorine, and then we get the repeat unit. So first we draw the polymer backbone and then we draw the repeat unit. We have to then draw the repeat unit several times, as we can see. So this is the repeat unit. We can keep drawing it one after the other, and then at the end we draw the brackets. And for simplicity, we can only draw one of the repeat unit, and then we open up brackets, and then we put the letter N, which refers to N unit of or N molecules of the monomer joined together to give you the polymer. So what if we know the structure of the polymer? Can we deduce the structure of the polymer from the repeat unit? We can do this by simply looking at the repeat unit or trying to find the repeat unit. Remember that monomers is just repeat unit. So we can replace the carbon-carbon single bond between the backbone carbons with a double bond, and then we remove the brackets and then we remove the additional single bonds on the sides and the brackets. Then we will get our monomer or the original monomer that formed the polymer. So an example of that is Teflon. So if you are provided with part of the structure of Teflon or of an addition polymer like this, how can you find the structure of the monomer? The first thing you need to look up which part is repeating. When you look up the repeating part, it always has to be two carbon atoms within the main chain of the structure. So the repeat unit will be 2 carbon long, as we can see. So any 2 carbon long here, you can use them. And then you start putting the different substituent on the carbon. And then you only need to add the double bond, remove the extra a single bond, and then just add a double bond between the two carbon atoms. Then you now have the monomers of, or the alkene, the monomer that form that particular polymer. What are the properties of the addition polymers? Polymers chains are saturated because they only have single bond. There is no double bond here because we removed the double bond by the addition reaction or by the addition polymerization. And so they are nonpolar and unreactive. Are held together via van der Waals forces, as we know that non-polar compound, the alkanes, are held together via van der Waals forces. The longer the chain and the less branched the chain, as we can see, the chains will be more closer to each other, and then there will be a stronger van der Waals forces between the different chains. So long and straight chains are tend to be strong and rigid, while short and branched chains will be weaker and more flexible because the branching and the shorter chains means that there is less van der Waals forces. The polymer chains will not be closely packed together as in the same type of and in the same way as the straight chains. Can we modify the properties of addition polymers? Yes, this is through the addition of plasticizers. So plasticizers will make the polymers more flexible. Plasticizers will come between the layers of the polymer or the chains of the polymer, and then they will reduce the strengths of the intermolecular forces between the different chains, and then the chains can easily slide around each other more, and the polymer can then bend. An example of one of the polymers that the properties of it can be modified by adding a plasticizers is the polyvinyl chloride or PVC. Polyvinyl chloride is form a long, closely packed polymer chain. So PVC is brittle at room temperature. The rigid PVC is used in drain pipes and in window frames. However, when a plasticizer is added, the plasticizer will add itself between the chains of the polyvinyl chloride or between the chains of the polymer, and then the PVC will become more flexible now. So plasticized PVC is used to make electrical cable insulators, flooring tiles, and clothing because now it's much more flexible than the rigid PVC.